Hello viewers, in this video we'll see simultaneous equation method. Simultaneous equation method is the method here the service rendered by each service department to other departments is estimated here. Okay, by solving the simultaneous equation, algebraic equation. Okay, one service department may render service to another service department and also to the production departments, and in turn it receives the service from the other service department. Okay, and a simultaneous equation method is the method where the amount of each production department can be obtained by solving the simultaneous equation. Okay, based on the percentage of service estimate, simultaneous algebraic equation will be formed, and based on that the total overheads of one service department is considered as X and the other service department as Y, and the simultaneous equations are solved for the values of X and Y, and based on the value the overhead of each service department is directly transferred to production department. Okay, let's see the problem. Now then you'll come to know what is this simultaneous equation method. Yes, here we have a problem. In a factory, there are two service departments P and Q and three production departments A, B and C. In April 2005, the department expenses were, okay, these are the production department A, B and C, and the overheads as per primary distribution are this, and this is service department P and Q, and the cost of P is 1,20,000 and Q is 1 lakh. The service department expenses are allocated on a percentage basis as follows. Okay, based on this percentage, the overheads are allocated to the other production department and as well as for the service department. Okay, P's overhead is allocated to A, B and C and Q, and Q's overhead is allocated to A, B, C and P. Okay, prepare secondary distribution summary under simultaneous equation method. Okay, let's start doing the problem. Okay, first we have to take the X to be the total overhead of department P. Okay, and this is to be taken as X. Okay, and similarly, and Q's overhead is taken as Y. Okay, we have to assume like that. Okay, P's overhead is taken as X and Q's overhead is taken as Y. Okay, and X is nothing but 1,20,000 plus the percentage of Y, that is 5% X will get from Y. Okay, so 1,20,000 plus 0.05 Y. Okay, and now similarly for Y it is 1 lakh plus it gets 15% from X. Okay, so we have to write it here. Y equal to 1 lakh plus 15%, we can write it as 0.15x. Okay, this is the equation we formed. Okay, now we have to solve this equation in a algebraic form. Okay, in order to eliminate one variable, that is X or Y, we have to eliminate one. So first we'll eliminate Y. So for that we multiply the second equation by 0.05. Okay, if we multiply this equation, we'll arrive this. See, Y into 0.05 will get 0.05Y, and 1 lakh into 0.05 will get 5,000, and 0.05 into 0.15x will get 0.0075x. Okay, we'll arrive a new equation, that is 3 we named. Okay, and the next step we have to rearrange the equation 1 and 3. Okay, because we have to bring the variables to one side and the constant number to the other so that we can easily solve the equation. Okay, first see the equation 1 will bring this Y to left hand side, so it will minus 0.05y, and in the right hand side we'll write 1,20,000. And similarly equation 3 will bring this x to left hand side. So minus 0.0075x. Okay, and this will write here plus 0.05y equal to 5000. Okay. Now we can eliminate this y. Okay, because here we have minus y 0.05y and here we have plus 0.05y. So we can eliminate this. Okay, if we eliminate, we will get 0.9925 because here 1x we have. So 1 minus 0.0075 will get 0.9925x. Okay, and here if we add this, we'll get 1,25,000. So the value of x 1,25,000 divided by this 0.9925 will get 1,25,945. Okay, we got x here, and now we have to substitute this x in order to get y. Okay, if we substitute the x in equation 1, this is the equation 1. If we substitute x in that, okay, we'll get y equal to 1,18,900. Okay, see 1,25,945 if we substitute here, it will goes to that side, will get 5,945. So if we divide that by 0.05, we'll get 1,18,900, and this is the value of y. Okay, using this value of y and x, this y and x is nothing but x equal to p and y equal to q. So I have written here. So now we have to allocate this on the basis of the percentage given. Okay, see, this is the format. Secondary overhead distribution summary. I have written the overhead as per the primary apportionment. Yes, for A 6,50,000 and for B 6 lakh and for C 5 lakh. Okay, and the next step is that we have to add the service department P's overhead. We found no, this is to be allocated to A, B and C in the ratio of this. Okay, 30 is to 40 is to 15 is to 15, but we need not give it to Q. Okay, we can stop up to A, B, C. But I have taken the percentage, converted the percentage into ratio. Okay, 3 is to 4 is to 1.5 is to 1.5. Okay, if we allocate this in this ratio, we'll get 37,784 for A and 50,378 for B and 18,892 for C. This is nothing but 1,25,945 into 3 by 10. Okay, and for B 1,25,945 into 4 by 10. Okay, and 1,25,945 into 1.5 divided by 10 for C. Okay, and next we have to allocate the Q's overhead to the A, B and C in this ratio. Okay, 4 is to 3 is to 2.5 is to 0.5, but we need not allocate to P. Just I am giving the ratio I have written here. Okay, so 1,18,900 into 4 by 10 will get 47,560, and similarly 1,18,900 into 3 by 10 will get 35,670. Okay, and similarly 1,18,900 into 2.5 divided by 10 will get 29,725. Okay, and next thing is we have to just add this. Okay, if we add the 6,50,000, 37,784, 47,560 will get 7,35,340. This is the total overhead of A. And similarly for B is 6,86,045. And similarly for C will get 5,48,615. Okay, I hope now you understand this problem, and I have given you a small problem for you to practice. Okay, thank you for your patient listening.